Good morning, dear friends. In the last session, we have seen what is meant by resistance and what is meant by inductance, and also what is meant by capacitance. When they are connected in series, what is a R equivalent and capacitance equivalent and the inductance equivalent. In this today's session, we are going to learn about what is meant by open circuit and the short circuit. So before you understanding this open circuit and short circuit, you should know in series connection what is the voltage and current relation, and the parallel connection what is the voltage and the current relation. So for that, let's see first the series connection. We have two resistors are connected in series. So the resistance will be R1 and the R2, and the voltage across this circuit will be V. So now we have given here positive as well as negative. Okay. So now when the current, if the current is flowing through this, okay, that the current is flowing through this, the current will enter to this resistance and leaving from this and again entering to this R2 and coming back. If you assume this current which is flowing through the resistance is I1 and current which is flowing through the resistance is I2. So the total current is I. So this all the current will flows through this and come back. So in this case, I is nothing but I1 and nothing but is equal to I2. Both the three currents are same. Total current I is equal to I1, that is equal to I2. So at the same time, as the current is flowing through this, it will has some voltage drop. That voltage drop I will write it as V1. This voltage drop across the resistance is V2. So as per the Ohm's law, the voltage across the resistance resistance R1 is V1 is nothing but current which is flowing through the resistance R1 and the multiplied by R1. Okay. So now already we know I1 equal to I. So we can write I into R1. Similarly, the voltage drop across the resistance R2 is nothing but I2 into R2. Okay, I2 into R2. Already we know I2 is equal to I1 equal to I. Therefore, I into R2. So from this, we can conclude that when this resistance, if the resistance is varying, if for example, when the resistance R1 is greater than R2, the voltage across V1 is greater than, voltage across resistance R1 is greater than R2. Similarly, when the resistance R1 is less than R2, the voltage across resistance R1 will be less than R2. That means voltage is directly proportional if this current is constant and resistance is varying, right? So when resistance R1 is equal to R2, we can say V1 is equal to V2. Why? Current is same. That's why V is equal to V2. So from this, we can total voltage is nothing but V is the total voltage, that is nothing but V1 plus V2. So in this series, this is for series connection. Okay, this is for series connection. In the series connection, voltage equal to V1 plus V2 and current is equal to I1 is equal to I2. That means what we can conclude from this is when the two resistors are connected in series, the voltage across each resistance will be different. The total voltage is nothing but sum of the voltage drop of each element, that is V is equal to V1 plus V2. At the same time, when the current is same, the same current will flows through the resistance of the two elements, our resistance R1 and R2. So we can say I is equal to I1 plus I1, that is equal to I2. So I hope you understand what is the relation in this voltage and current in the series connection. Assume that now the parallel connection. In the parallel connection, we have two resistors. Both are connected in the parallel. Okay. So this is R1 and this will be R2. Current flowing through the resistance is R1 is I1. current flowing through the resistance is R2. So this is the supply voltage V. Okay. So now the voltage across this resistance we can write I1 into R1, that we can say V1. The voltage across this resistance is I2 into R2, that is equal to V2. So now this terminal is positive, this terminal is negative. Assume this is one joint and this is another one joint. So this positive will be here and this negative will be here. In the parallel connection, this voltage is same here. Okay, voltage is same here. So now what we can say, voltage V1 is equal to voltage V2, that is equal to V in the parallel connection. At the same time, the total current is here I, that is going divided into I1 plus I1 and I2, and return back here again return I. That means we can say I is equal to I1 plus I2. From this, what we can conclude is, when the resistance here we know I is equal to V by R. So when the resistance is increasing, current will reduce. When the resistance is reducing, current will increase. So accordingly, this I1 and I2 will vary based on the resistance R2. At the same time, voltage is same. V is equal to V1 equal to V2. So from this, what we can conclude, in the parallel connection, voltage is same. In the parallel connected circuit, all the voltage across the elements are same. At the same time, current which is flowing through the each element will be different. The total current is nothing but sum of the current which is flowing through the each circuit or each path. So that's why I is equal to I1 plus I2. So from this we can conclude totally, the open circuit voltage is same, current voltage in each element is same, current will be different. In the short circuit, current will be same, voltage will be different. So voltage across the resistance R1 we will write V1 equal to I into R1. V2 is nothing but I2 into R2. So in this case, I1 is equal to I2 equal to I in the series connection. Okay. So now let us understand what is mean by open circuit and the short circuit. What is mean by open circuit and the short circuit? So for making you understand this concept of open circuit and short circuit, so let us see this now. We have the same circuit of the parallel connection. We have the resistance here R1 and we have the resistance here R2. So both are connected in parallel. So this is the circuit. Supply voltage we have given as V. So this is positive and negative. This is R1 and R2. So now the total current I divided into I1 and I2. So the voltage, already we told you, voltage V1 equal to V, that is I2 into R2. Similarly here, this is V2. Okay. So now here V1 equal to V equal to I1 into R1. Already the concept is very clear. Now what I am going to do in the circuit, I am removing this resistance. Okay, I am removing this resistance and making it open circuit. Not removing, just I will disconnect this resistance and making this path as open circuit. So let me use in another one color. So this is the path. Now if you see this, here this is the resistance, current is I1. Okay, so the current is I1. So whether the current will flow through the circuit, through this path, this is open, right? So there is no electron flow between the open circuit. So what is the quality of resistance? It will oppose the flow of current. So as it is flowing, entirely current flowing through the circuit is opposed or stopped. We can say that here the resistance is infinity. That means resistance is maximum. So this is called as open circuit. The circuit here, it is totally open. So there is no current flow at all, right? There is no current flow at all. So that the resistance is infinity. The resistance is less means current flow will be maximum. When the resistance is maximum, current flow will be minimum. So in our case, there is no current flow. That means I1 is equal to 0. So now, if you see, this is the current here, it is entering, and current it is leaving. Can you tell me what is the value of I1? What is the value of I1? I1 is 0, and at the same time, what about I2? I2 is equal to total current. Already we know in the parallel connection, I is equal to I1 plus I2. So as I1 is 0, I2 equal to, I is equal to I2. For better understanding, right? Mathematically also we can prove. Here we know Ohm's law, V is equal to I into R. Okay. Now from this, what is I? I is equal to V by R. Right. Now in this circuit, I am going to take I1 equal to V1, that is equal to V divided by R1. This is R1. Right. So what will happen? Here already we know R1 is equal to infinity. Therefore, I1 equal to V by infinity. Any value divided by infinity is equal to 0. Any value divided by infinity equal to 0. That's why here we can see I1 is equal to 0. At the same time, voltage. Here the resistance, here the current is 0. Therefore, the voltage across this, here the current will be automatically 0, right? So now, here if you see this terminal is appear across this. Already the parallel connection, voltages are same. So the resistance is maximum. So that at the same time, current will be flowing through this path. So we can say, we can redraw the circuit as here R2, and this is the supply voltage V. Supply voltage V, this is the current I and returning back current. Therefore, the voltage is nothing but I into R2 only. Since this is open, this voltage, this is looks like same. We can remove entirely, right? Circuit entirely. So this voltage will appear across this. So V is equal to I into R2. Okay. So now this in this circuit, in this case what happened? Voltage is also maximum. The voltage is nothing but V is equal to I into R2. The entire parallel connection. This terminal voltage is equal to. So we can only to worry about this connection since there is no current flow, entirely it is open. Okay. Then let's see about this short circuit. Assume the same circuit. We have the resistance. We have the resistance is R1, and we have another one resistance is R2. And we have the supply voltage is V. So current is entering here, current is leaving here. So now I1, I2, this is I1. Okay, I2, I2. What I am going to do, I am taking one wire and taking these 2 points. Assume this point as A and this point as B. I am shorting here. Okay. So when I short like this, that is called as short circuit. That means here the resistance is equal to 0. Resistance is 0 means there is no parameter which will oppose the flow of current. We know parameters which will oppose the flow of current. So that resistance equal to 0. Always the current will flows the easiest path. So when it comes to this 3 path, this path is very easiest way to return. There is no resistance. So what happen? All the current the path will be, all this current I will be flows through this and go to the short circuit path and come back. In this case, what happened? The current which is flowing through this I1 is equal to 0. Current which is flowing through I2 equal to 0. I can take this one new branch I3. Only I3 only the maximum current will flow. As per the parallel law concept, the total current I is nothing but I1 plus I2 plus I3. So that I1, I2 already 0. So that is equal to I3 only. Okay. If you want to do it in mathematically, assume this resistance you can take R3. R3 equal to 0. So the branch voltage V3 equal to I3 into R3. Now we are already we know I3 equal to V3 divided by I3. So V3 is nothing but we can say same voltage, right? Parallel connection voltage is same. So voltage divided by R3 is 0. So any value divided by 0 is infinity. So what happened? As when this in the parallel connection, if the short circuit is occur, all the current will flows through the short circuit path. Therefore, we can say that I3 is maximum. Ideally, we can say infinity, but in your practically what is the maximum current is how much current? I current is flowing, so we can say that I. So what about the voltage? So already we know the voltage V3 equal to I3 into R3. The resistance is 0. Therefore, V3 equal to 0. So what happened? As this all the current is flowing through this, it will there is no current flow here, right? I2, there is no current flow in I1. It is looks like open circuit. This looks like open circuit since there is no current flow, right? When there is no current flow, when the resistance are more and there is no way of current to flow, so that's why it is open. So we can see, we can redraw the circuit. We have like this only. What is this? This is the voltage and this is the current. What current? I3, and I it is flowing. So if you see this entire current is maximum, so automatically V3 or V, the total voltage across this will be 3 equal to 0. So what I can conclude is, if we in the short circuit, if we connect, assume that we have two parallel path, one short and another one is having the resistance. Assume one ammeter connected here, and if you connect this voltage here, voltage supply, assume we are connecting one voltmeter as well. So in this short circuit, we can see the total current I is maximum current will flows through this. Current will be maximum. At the same time, the voltmeter reading will be 0. Similarly, in the open circuit, assume we have the open circuit here. If I connect one voltmeter in this open circuit and the current ammeter current, if I connected, so what happened? The open circuit current is 0, voltage is maximum. So this is what we understood. Okay. So from this today's session, we understood that what is meant by series connection, what is meant by series connection and parallel connection, what is the voltage across in the series connection and the parallel, and similarly current in the series and parallel. Also we understood what is meant by open circuit and the short circuit. So we can conclude finally, in the series connection, current is same. Current flowing through the each element is same, and voltage across the each element is different. It will vary with respect to the resistance. Similarly, in the parallel connection, voltage is same, current will be different. So we can say current is I is equal to I1 equal to I2 and voltage V is equal to V1 plus V2. In this parallel connection, voltage V is equal to V1 equal to V2. Current I is equal to I1 plus I2. Okay. Then second one, in the open circuit, voltage is resistance is infinity. Resistance is maximum. Therefore, voltage is also maximum or infinity. Ideally, we can say infinity. Current will be 0. At the same time, in the short circuit, what is that? Resistance is 0. Therefore, voltage is 0 and current is infinity or current is maximum. I hope you understand the difference. So, before coming to the next session, I will give you one small assignment. Just to try to solve it and just mention the answer in the chat box. Assume we have one parallel series resistance and we have one parallel and we have one open circuit here. Then again we have one parallel resistance. Assume this resistance can be R1 and resistance R2 and resistance, you can take this resistance as R3 or 4. The voltage across this, we can take it as 230 volt. Okay, voltage across is 230 volt. You can take this is 1 ohm and 2 ohm. Then this is 3 ohm. The open circuit R3, you know what is the value of resistance. Now, I want to know what is the voltage across resistance R1 and voltage across resistance R2, voltage across resistance R3 and voltage across resistance R4. Similarly, what is the current flowing through the resistance R1, what is the current flowing through the resistance R2, what is the current flowing through the resistance R3 and what is the current flowing through the resistance R4. In the same circuit, for this is for figure A. Assume now figure B. Mention here separately what is V1, V2, V3, V4. Similarly, I1, I2, I3, I4. Now you take the same circuit. Here we can have the resistance and here the resistance. We have a short and resistance R4. R4 is 3 ohm. Then you can take this current I1. So this is R1 equal to 1 ohm. Same voltage we have given. V is equal to 230 volt. Therefore, here the resistance is R2 equal to 2 ohm. Here you can take resistance R3 and R4. I want to know the voltage across the resistance R1, that is V1, voltage across resistance R2, voltage across resistance R3 and voltage across resistance R4. Same way, current flowing through this I1, I2, I3 and I4. You can mention this answer for figure B. V1, what is V2, V3, V4. Similarly, I1, I2, I3, I4. So this exercise will help you how to analyze this values, and that explanation I will give it in the next class. I hope the topic of open circuit and short circuit, series and parallel connection, voltage relationship, all those things so much understanding, and it is easy to solve the problems as well. So that I hope you can clearly solve this. Those who like this channel, kindly subscribe and share to your friends and press the bell button as well, so that forthcoming video you can access it very shortly. Wish you all the best. Thank you.